Hello and welcome to Reill's tutorial. We'll continue with AP Physics 1 in this video, but there will be a new topic today called kinematics. Please like, subscribe, comment to encourage me to upload more videos. Thank you and welcome. Okay, so today we'll be working on kinematics. First, what is kinematics? As the name describes, kinematics. Kinematics talks about an object in motion. Kine is derived from kinetics, motion. Matics is calculation. So it's simply kinematics are the mathematical tools for describing a motion in terms of displacement, velocity, and acceleration. Let me now come back to base. When we say kinematics, let me explain. It talks about how far an object travels, that is distance travel. There's a calculation there. How fast, in what direction does it move? Does it go left? Does it go right? If you remember from our previous video, which I'm going to add to this link, we talked about vectors in terms of direction. So this thing was how far does it move? And at what rates is the speed changes? Does it change at high speed or low speed? Does it accelerate? Does it decelerate? That's what kinematics is all about. And in kinematics, we have series of subtopics in kinematics. There's position, displacement, distance versus time graph, speed and velocity, acceleration, like your car, when you press the pedal, it moves faster, uniform acceleration motion, and the big five, kinematics graphic acceptions, qualitative graphing, free fall, and projectile. That is going to be the last subtopic in kinematics. But for today, we'll be working on just a little bit of these topics. On this video, we're working on just a few of these topics. We can't handle all this topic in one video because it's going to be very overwhelming. So what we're working on today will be position, displacement, and distance time graph is what we'll focus on in this video. So let's keep moving. Position. When we say position, we're talking about a point, an object at a location. Like when you have your car parked, that is your car is at a position. It's parked at a position. When you're standing at a point, that is a position. That defines a position. When you have your pot on the stove, the pot is in its position. So coming back to physics and this graph, when you look at this graph that I have here, this object here is at this position. It's at the position between the x and the y axis. It's at this position. That's where the object is rested. That's how you define a position. And in the graph, there's always an origin in the position. This is the origin. A circle is its origin. The origin of this graph is always 0. It's either 0 on the x-axis or 0 on the y-axis. It's always 0 because the origin is mainly at rest. When you hear an object at rest is 0, the origin is 0, always 0. So since this graph is in this form, as you move further in this graph on the x-axis, you have 1, 2, 3. On the y-axis, so negative x-axis and negative y-axis. So this point here is always the origin. So the position, it could be at any position. The object can be on the x-axis on position 2. It can be on the y-axis position 3. It's just the position. So let's assume this graph, this object standing here. If one say what's the position, it can either be in position of y2 and x2. If you draw the line here and line here to show you a position where it is. It's just a position, a location. Your heart is in a position because it has an address that defines the location of where it is. Okay, let's move on to the. So now in displacement, what is displacement? Displacement, like the name entails, is changing position. An object change in position. So now an object that starts from point 0 and move to another location. You can start from point 10 to point 20. An object change in this position is called displacement. Now, looking at this drawing here on this part, this is a house. This is house A, and this is house B. A boy comes out of house A. Starting point is 0 meters, then goes to house B. Starting point at end point is 20 meters. So the displacement is the distance. A to house B is 13 meters. That is what displacement defines. It's just a change in position. Let's go back to regular things. Once you're in your car, your car is parked at a particular position. You get into the car, you start up a car, then you drive the car to school from your house. Your house will be point 0. Then you drive your car to school. Once you get to school, let's say the school is 300 kilometers away from your house. So that distance from your house to school is 300 kilometers. That is the distance travel. That is what displacement is all about. At the back of your hand, mind, remember this place is to change something. This place is displace something. Displacement, the change, objects changing position. That is what displacement is. And displacement is always in meters. The unit of displacement is always in meters. So let's always remember that. Okay? Example on this displacement. Looking at this example, the example shows that an infant crossed 5 meters east, then 3 meters north, and then 1 meters east. Find the magnitude of the infant's displacement. We're looking for the magnitude of the infant displacement. We're looking for this magnitude, that is the word, of the infant's displacement. But now let us draw the distance travel. Come with me, let's draw it. An infant crawls 5 meters east. It is 5 meters east, 5 meters, and then 2 meters north, 2 meters north, sorry, 3 meters north, 3 meters north, and then 1 meters east, then 1 meters east, 1 meter. So we're looking for the displacement of this travel. So the displacement is we're going to have to find from the start point to the end point. That is from here all the way to here. That's what we're looking for, the displacement. Normally, the distance travel could just be 5 plus 3 plus 2. Distance travel, the distance will just be 5 plus 3 plus 1. And that will give us 9 meters. That's the distance. But now we're finding the magnitude of the infant's displacement. We're looking at the magnitude. That is why we have to apply this. Now we have to apply this Pythagoras theorem. And this Pythagoras theorem, if you draw the line from here, it's just the same thing as, it's almost like a triangle. Because if we replicate this line here, with dots, this is also 1 meter. Then take this one down here. This is more like a triangle. So it's similar to having this, this, and this. So this one will be 5 and 1 here. The first distance travel, 5 meters, and the last meter to the east, that is 1 meter, that is 6 meters here. Then traveling north is 3 meters, 3 meters here. So now we're looking for the displacement, we're looking for the D. And seeing this, we know we'll have to apply Pythagoras theorem. If you remember from our last video, we mentioned about calculating the magnitude of a vector where you apply Pythagoras. This 6 is on the x-axis, so it's x squared plus, and 3 is on the y-axis, y squared. First populate this answer. The x is 6, so 6 square plus 3 square equals to 36 plus 9 is 45. So the square root of 45 will give us 6.7 meters. Therefore, the magnitude. Now, we're looking at distance time graph. What's the distance time graph? Distance time graph is we have, and the distance time graph is distance d over time. The units will always be in meters per seconds because time is in seconds, distance is always in meters. That is one part we should always remember. Okay? Now, looking at this distance time graph, it tells us about the distance traveled. This is the distance, the d, over the time traveled, the t. In looking at this graph, we see this position that has the object started from the origin, which we mentioned earlier, which is 0. And from the origin, it displaces itself to 10, that is here, to 10 meters in 1 second. Because this time is in seconds and this distance is in meters. So it travels in 10 meters in 1 second. But it maintains its position in that did not change this distance. In that same 10 meters, it was 8 seconds to this 1 second. That's 3 seconds. Then when it got to that 3 seconds, it started decelerating, reducing, stepping down, going back to the origin. From 10 meters, it went back to the origin of 0. So it added in the next 2 seconds, it went to the origin of 0 and became, in fact, at 5 seconds of the time now. Got to the origin of 0 at 5 seconds. Then when it got to 0, it descended again to 6 for 1 second, that is in 6, and got to -5. So it has traveled from origin to 10, from 10 back to origin to -5 was the end stop point. So the whole time traveled was 10 seconds, and it travels from 10 minus 5 seconds. That is the whole distance traveled, is this seconds. Since this is in this format, the easiest way to look at this is to organize them in segments. So we can call different segments. We can call this part, this one is segment 1, call this segment 2, and call this segment 3. Aligning the segments in that form, so it's easier to calculate. So this segment 3 will just be in that form as segment 3. And if you want to draw the segment 3, we'll draw it all the way down to this point, so that we'll know from 10 to this is the diameters, is the length. That's segment 3. And another way to calculate this distance times graph is, since you're in segments, you're seeing different shapes. So this is a triangle, this is a rectangle, this is another triangle, a big triangle. And we know from here to here, this point here is 10, and this is 1. And for us to find the area of a triangle, for the first segment, segment 1, the area of a triangle is half base times height. In this case, the base is from 0 to 1, that is 1, that is half times 1. Then the height will be 10, 0 to 10 is 10 times 10. So if you multiply this together, the answer will be 5 meters per seconds. Per seconds. That will be the distance traveled here. Does it make any sense? Because unit of this is meters per second. Then if we look at the next one, segment 2, we know the distance traveled. This one is going to be a rectangle, right? So now and the unit of rectangle is length times the breadth. Now the length of this is always the longer part. The length here is 10, and the breadth is 3 minus 1, that is 2, times 2. And that will give us 20 meters per second. Then the third segment, segment 3, that is here, is a triangle. So it will be half base times height. That is half times. Now the base is from 3 seconds to 6 seconds. Then we subtract 3 from 6, we get what? 3 seconds. Times, that is 3 seconds. Then the height is from 10 meters to -5. So 10 plus -5 is what? 5. That is 5. So 3 times 5 divided by 2 will give us 7.5 meters per second. So now for us to calculate the total time graph of this will be add 55 plus 20 plus 7.5. That will be 5 plus 20 plus 7.5. And that would give us what? This is 12. That will give us 32.5 meters per second. That will be the answer for this distance versus time graph. I hope this was clear enough for you. This is the end of the videos for today's video. You can like, subscribe, and comment. Make a comment if you have any question, write them on the comment section. I can explain them better again on the comment section for your understanding. And follow my channel so they can encourage me to make more videos. And just a quick reminder, this is my early stage of making videos. So I appreciate recommendation. Like if my speech pace is very fast, I could slow down a bit. If my teaching skills is pretty fast, I could step back a bit for better understanding. I'd appreciate if you like, subscribe, and comment so that it will encourage me to make and upload more videos. Okay, thank you, and thank you again for watching Reill's tutorial. And I appreciate if you come back again and watch Reill's tutorial. We are happy to teach you more. Happy student, happy physics, better understanding. The goal here is gateway to success. Okay, on to